Good morning, students. Today I am going to explain about interrupts. What is meant by interrupt? Interrupt means it is a disturbance. Interrupt is a signal given to the microprocessor to perform a specific task, or interrupt is an instruction given to the microprocessor to perform a task. There are two programs are available. One is called as main program, another one is called as interrupt program. Main program, that is called, it is represented in white color. This is called as main program and this is called as interrupt program. First, it will start executing from the main program. So there are first instruction it will execute, second, third, fourth, like this. There are 7 instructions are there in the main program. And in the interrupt program, there are 4 instructions are available. First, it will execute the first instruction, second, third, fourth. So when it is executing the 4th instruction, one interrupt is coming to the microprocessor. Or if you give some, you can give some instruction as interrupt or external signal. So anything we can give. So now you take external signal is giving an interrupt to the microprocessor. So what the microprocessor do means it will stop the main program and it will go to the interrupt program. After it will go the interrupt program and will start executing the first instruction, second, third, fourth. After completing the 4 instruction, it will return back to the main program. So that is a 5th instruction it will come. So after that 6, 7, it will complete the main program. This is the process of the interrupt. So let us see another one example. Here, this is in a classroom. There are students are there and teacher is there. Teacher is taking class. In the if you take college as an example, principal is the highest priority, vice principal is the next priority, dean, HOD, faculty, non-teaching, and student. Student is the lowest priority. So if the staff is taking class, at that time, principal is coming to a classroom. So what the faculty will do means, he will stop the class and he will talk to the principal. After the discussion gets over, once again he come back and he will take the class. This is called as an highest priority. Classroom, the students are there and faculty is taking class. The last bench, the 2 students are talking. So that is the interrupt to the faculty. Next, I am going to give some more example. Suppose you are watching video in your mobile phone. During that time, if you receive any call, so the video will stop and you can attend the call. After attending the call, once again it will go back. You can watch the video. This is one example of interrupt. Another one example, if you are going in the road by car. So another one car is coming back. He is giving horn. So what we will do means we will not give path to that vehicle. Suppose some ambulance is coming means you will stop the vehicle and you will give path to the ambulance vehicle. So this is one interrupt. Next one is fire safety system. If you take one industry, so the industry, there is a lot of controller is available. Suppose if any place, any fire occurs, automatically it will give that as a highest priority and it will complete all other process and it will give some alarm and it will give call to the fire station and the fire extinguisher will work. So that is called as a fire safety system. There the interrupt will work. So there are various types of interrupt is available. First one is software interrupt, another one is hardware interrupt. Hardware interrupt means you have to give some signals. If you give some signals, clock signals, then an interrupt will occur to the processor. That is called as hardware interrupt. Software interrupt means in the program itself, we have to give the instruction. By giving the instruction, we are going to interrupt the processor. That is RST 0, 1, 2, 3, like that. There are 8 interrupts are there. This is called as software interrupt. Hardware interrupt means in microcontroller there are 5 pins are there. Trap, RST 7.5, 6.5, 5.5, INTR. In this particular pin, if any high signals comes, clock signal comes, so a interrupt will occur. This is called as hardware interrupt. Vector interrupt means if any interrupt comes, RST 7.5 means the microprocessor know, okay, this interrupt means we have to go and execute the particular memory location. That is called as vector interrupt. Non-vector means if any interrupt is INTR is called as non-vector interrupt. If that interrupt comes means the microprocessor don't know the interrupt program address. So that interrupt INTR, it will give the address. Based on the address, the microprocessor will go to this memory location. Next, what is meant by maskable, non-maskable? Suppose you take a mobile phone. Suppose I want to block a number. So that is called as a mask. So if you mask, what will happen means when somebody calls to your number, so you will not get the ringtone. That is called as a mask. So here, if you mask the interrupt, when somebody is giving any interrupt, it will not disturb the microprocessor. Non-maskable means that is we cannot disable the interrupt. That is called as a non-maskable. Maskable means we can disable the interrupt. Non-maskable means we cannot disable the interrupt. Next, we are going to see about the interrupt structure. This is the interrupt structure. There are 5 interrupts, hardware interrupt is available. First one is INTR, trap, 7.5, 6.5, 7.5, 6.5, 5.5, trap, INTR. So here highest priority is trap. There is a trap. This is the second one, third, fourth, fifth. Fifth one is INTR is the lowest priority. This is the first point. Next one is 7.5, 6.5, 5.5. These 3 interrupts we can disable. You can enable and we can disable. But the trap, it is called as an INTR also we can disable. But trap, we cannot disable the trap interrupt. So trap is called as a non-maskable interrupt. Remaining all are called as maskable interrupt. What is very maskable means? Here there is an AND gate is there. AND gate. I am giving an interrupt signal to this RST 7.5. So this pin will become as high. But I am making here 1. So here not means 0. So automatically what will happen means the output will be 0. So this is given to the microprocessor. So if the interrupt comes, if you disable the interrupt, automatically it will not give any signal to the processor. But see here trap, it is directly connected to the microprocessor. So we cannot disable the interrupt. Next one is vector interrupt. 7.5. If any interrupt comes in this particular pin, it will go to the memory location 0030. 6.5 means 0034. 5.5 means 002C. So trap means 0024. So it is called as vector interrupt. If any interrupt comes in INTR, so it will not go directly to the memory location. So it is called as non-vector interrupt. Next, there are triggering. What is meant by triggering? So here this is called as clock signal. So first RST 7.5 is called as positive edge triggering. 6.5 level, 5.5 level. Trap is both positive and level. INTR is level. So when this is called as low signal, the next is go to high. From the high, 1 second it will be low. So when it reaches the high level, at that time only, it interrupt will pass to the microprocessor. That is called as level triggering. Positive edge triggering means from the signal is from low to high. During that period, it will interrupt the signal. RST 6.5, when it reaches the level, then only it will interrupt the microprocessor. That is called as an level triggering. Interrupt service routing. So there are 5 hardware interrupts are there. If any interrupt comes, automatically it will stop the main program and it will go and execute the interrupt program. So that interrupt program is called as interrupt service routing. So after completing the interrupt program, once again it will come back to the main program. So when example you take RST 7.5, when you are giving a high interrupt signal, so the microprocessor will stop the main program and it will go to the interrupt program. So during this time, it will change the program counter address as 0024, 003C. Earlier, the main program address is available in the program counter. Now, an interrupt occurs. So what will happen means, it will store the interrupt program address in the program counter and it will store the next address of the main program in the stack counter. So this process will happen when an interrupt is occurred, whether it may trap 7.5, 6.5, 5.5 or INTR. This is a tabular column. There are 5 interrupts are there. So higher priority is given highest to lowest. Trap is called as a non-maskable. Remaining all are called as maskable, means we can disable and we can enable. But trap we cannot disable. What is a vector address means, if any interrupt comes in the trap pin, the microprocessor know the address of the interrupt program. But any interrupts come in the INTR, the microprocessor does not know the interrupt program address. So the interrupt program address will be given by the external device. Thus, this is called as triggering, edge triggering and level triggering. There are 8 softwares are there. Software interrupts are available. What is meant by software interrupt means, in the program itself, we can interrupt the, we can give the interrupt to the microprocessor. So in the middle of the main program, we can give some instruction RST6. So it will go directly to this memory location 003C. These are called as vector interrupt. Disable interrupt. There is one instruction called as disable interrupt. If you give that instruction disable interrupt, all the RST 7.5, 6.5, 5.5 and INTR will get disabled. Set interrupt mask. So this is one 8-bit register. So if you give the instruction set interrupt mask from the accumulator value, it will store in the register. Accumulator value is stored in this register. When you store this register, example you take first bit as M5.5. If this value is 0, it is called as unmasked. If it is 1 means masked. Likewise, the first 3 bits are used. MSP means it is used to enable and mask set enable. Totally, first you are going to mask means you have to enable this pin. Next, if you want to reset 7.5, you can use 1. This is not used. These 2 pins are used for serial communication. So it is used to enable the serial output enable, and this is used to send the serial output data. Enable interrupts. Previously we have studied what is my disable interrupt. What is my enable interrupt means, disable means if you give 1, automatically what will happen means the interrupt will be disabled. If you want to enable means you have to use the instruction EI. Next, read mask. It is an 8-bit register. It will read the data from this register and it will store in your accumulator. Suppose I want to know the status of the interrupt signal, whether it is masked or whether it is not masked. So which interrupt is bending. So everything we can see the status. By reading this register value, we can know the status of the interrupt. The last 7th pin, it is 8th pin, it is used to for serial communication. It is used to receive data. SOD means it is used to transmit data. SID means it is used to receive data. This all about the interrupt of 8085 microprocessor. Next video, I am going to explain about the timing diagram of 8085 microprocessor. Thank you.